Good afternoon, friends, students, especially the persons either it's Mr. Mana or Mr. Joshi sitting at Amritsar Polytechnic. So, good evening to everyone. So, today I am going to discuss power factor and its importance. First of all, my name is Gurvinder Pal Singh. I am head of electrical engineering department at Government Polytechnic Amritsar. So, my mobile number is in front of you, 8968653344. The topic which I selected today to share with you, the power factor and its importance is very important. ਮੇਰਾ ਨਹੀਂ ਖਿਆਲ ਕਿ ਮੈਨੂੰ ਵੀ ਪਾਵਰ ਫੈਕਟਰ ਨੂੰ ਸਮਝਣ ਲਈ ਮੇਰੇ ਇਸ ਕੈਰੀਅਰ ਦੇ ਵਿੱਚ ਮੈਨੂੰ 5-6 ਸਾਲ ਲੱਗ ਗਏ ਸੀਗੇ। ਸੋ ਮੈਨੂੰ ਇਹ ਪਤਾ ਕਿ ਜਿਹੜੇ 5th ਸਮੈਸਟਰ ਦੇ ਸਟੂਡੈਂਟਸ ਪਾਵਰ ਫੈਕਟਰ ਪੜ੍ਹਦੇ ਪਏ ਆ ਜਾਂ ਚਾਹੇ ਉਹ ਇੰਜੀਨੀਅਰਿੰਗ ਸਟੂਡੈਂਟਸ ਵੀ ਹੈਗੇ ਆ, ਉਹਨਾਂ ਨੂੰ ਪਾਵਰ ਫੈਕਟਰ ਦੀ ਡੈਫੀਨੇਸ਼ਨ ਤਾਂ ਜ਼ਰੂਰ ਪਤਾ ਹੋਏਗੀ, ਬਟ ਦੇ do not know what the inside story of the power factor is. So today, with the help of slides and with the help of other techniques, modes and which I am using in this lecture, so I will try to give you somewhat approach to understand how to understand power factor. So first of all, you have already studied in basic electricity that we have references voltage and current. So ज़्यादा करके असी voltage ਨੂੰ reference ਲੈਂਦੇ ਹਾਂ, current ਨੂੰ ਅਸੀਂ lead ਜਾਂ lag करवाने हैं in electrical engineering. So in introduction, it is the common to define the power factor as the cosine of the phase angle between voltage and current, or this is known as cos phi. So you can see there is one vector V which is a reference vector, and there is another vector I. So this vector I lags behind voltage by an angle phi. First of all, while studying all these things, so I want to refer you to your previous class in basic electrical engineering. So you might have studied about the current flowing through resistance, current flowing through inductance and current flowing through capacitor. So this is the main and major cause of a creation of a power factor. So how the power factor is created in electrical engineering, this is all due to inductance and capacitor. So you see, in case of a inductor, the current in a pure inductor, in an ideal inductor, the current I is lagging behind the voltage, and similarly in case of a capacitor, I is leading the applied voltage by 90 degree. So in case of a inductor, I is lagging, in case of a capacitor, I is leading, but in case of a resistor, this is ideal case in which the voltage and current both are in same phase. So as you have seen in the phasor diagram for an inductive circuit, here voltage V is taken as a reference vector and current I lags the voltage by an angle phi. The horizontal component I cos phi known as active component. So we ਅਸੀਂ angle ਨੂੰ ਕਿਸੇ ਨਾਲ ਵੀ denote ਕਰ ਸਕਦੇ ਹਾਂ. You can denote angle by an angle theta, or you can denote angle by angle phi. So vector component and current I sin phi known as reactive component of current is perpendicular to the voltage vector. If all the three sides are multiplied by voltage V, then the power triangle is obtained. We will see in our next slide the power triangle. So VI cos phi is called the real power, which is measured in kilowatt or watt. The smaller unit is watt and bigger unit is kilowatt. VI sin phi is the reactive power, which is measured in kilovolt ampere reactive, and smaller unit is volt ampere reactive, and VI is the apparent power in kVA or volt ampere. So from this relation we can find power factor can also be defined as the ratio of real power to the apparent power. So VR cos phi divided by VI, it is cos phi. So I've already talked about the power triangle. So you see over here you can see a power triangle. The power factor can also be defined as the ratio of applied real power and the apparent power, and generally expressed as, so power factor is the ratio of real power to the apparent power. So we can express real power as Vi cos phi and apparent power is Vi, and if we calculate the ratio of these two, it comes to be cos phi. So in the downside of the slide you can see a vector which is horizontal, which is known as real power, and the vertical vector is reactive power, and the hypotenuse the vector is kVA, apparent power. So power factor can also be defined as the, in case of a resistance, impedance and inductor or capacitor. So we can define as the power factor as the ratio of R to Z. So R, in case of a resistance, the current is always in phase with the voltage. So in case of a inductor, current always lagging. In case of a capacitor, current always leads the voltage. So Z is the total impedance of the circuit. So it is the ratio of if you know the trigonometrical T ratios. So T ratios in trigonometry, you can find the cos phi is R over Z. R in trigonometrical term, it is base divided by hypotenuse. So I have a special slides. So in these slides I will try to understand you that what power factor mean is. So ਸਾਨੂੰ power factor ਦੀ ਲੋੜ ਕਿਉਂ ਪਈ, power factor why it is so important in electrical engineering. So you see in the left hand side of my slide there is a heater and a bulb. In the right side there is an induction motor. So we have resistive loads. So this is known as resistive loads, like lamps consumes real power. So these lamps and heaters, they are pure resistive circuits and they consume real power and no reactive power. So they don't consume any reactive power, versus we have a motor, induction motor. So motors and coils, you see you have plenty of motor in your houses. You have talus pumps, you have submersibles, you have air conditioners, you have ceiling fans, you have table fans, exhaust fans, you have a washing machine, you have microwave oven, you have a induction, any type of induction furnaces. So all these motors draw lagging current. So that lagging current, if you know more technically, it is known as magnetizing current. So in case of motor and coils, while consuming some real power, so motors, they consume real power as well as reactive power. As in case of resistors, they consume only real power. So some reactive power, this power is wasted. So in case of a reactive power, this power is wasted in the electrical circuit, while in the resistance they use only real power, no power is wasted. All power is in heater, the total power is converted to heat. In electric bulb, the total power is converted to light. But in case of induction motors, in case of inductors, so real power, total power is converted into real power and reactive power, and the reactive power is the power wasted in a machinery. This power is wasted in a magnetic fields and does not work. So this power does not work. Now in the, we can see in the slide, left hand slide, you see the voltage vector and the current vector. So left hand side is the sine wave. You can see this is a pure resistive load. When voltage is given to a pure resistive load, the current and voltage are in same phase. You can see the angle theta between the voltage and current is 0. But you see the right hand side of your slide, you see the voltage and current vector, they both are, current is lagging behind the voltage by 90 degree. So this is ideal case. So this is a totally inductive circuit, ideal inductive circuit. in which the current lags behind the voltage by 90 degree. So, when we are examining the vector diagram of the resistive load, we find the current is in phase with the voltage. So, in case V and I, the angle between voltage and current is 0, but in case of a inductive circuit, the angle between voltage and current is depends upon how much the circuit reactive is. So, maximum it is 90 degree, and we can generalize it by an angle theta or phi. So, you can again see the phasor diagram. So, you see in a pure resistive load, the current and voltage both are in same phase. So, these are the vector diagrams of voltage and current. So, we have also examined the inductive load. So, in inductive load, the current is lagging behind the voltage by an angle theta. Again, third, we have a capacitor. You can see the figures of a capacitors. We have a different kind of capacitor in this slide. So, you can see the quality of the capacitor is to draw a leading current. So, reference again there is a voltage and the current is leading by an angle phi. So, it is a generalized the current I is leading the applied voltage by an angle phi. So, this is in the case of a capacitor, and this property of a capacitor is used to modify the power factor or used to improve the power factor, which we will study in the next slides. So, again I try my level best so that you people can understand what is power factor. So, this is an example to understand what is real power and what is the reactive power. Suppose you see in this diagram, in this slide, the horse is consider the load is pulled by a horse. So, we have a load, the horse is pulling the load along the river. So, river जिस पासे चल रहा horse load उसे बन नहीं खींच रहा. So, try to understand it. The horse is pulling the load in the same side of the river. So, the power consumed by the horse is known as real power. So, over here we can say the angle between the line of the horse and the line of the river is 0. So, we can say the voltage and current vector both are in same phase, and the horse is pulling the load with less efforts. Now, this is going to clear your fundamental. Now, you see the same horse is pulling the load by an angle theta. So, load is moving along the river, but the horse is at applied pulling the load at an angle theta. So, you see the horse has to consume more power to pull the same load as before. So, you see now this power which now the horse is applying more power, and this more power is the reactive power, which is I have shown you in dotted line. So, this power is wasted. So, this power have no use. So, similarly in our electric system, so to explain this, the real power worked in an electrical system similar as the load is pulled by a horse in the line of the river. So, I have already told you that in heater we consume real power as the horse is pulling the load along the river, but in case of a inductive circuits, in case of a motors and other inductive loads, the horse is pulling the load at an angle theta. So, it is consuming more power, real power plus the power wasted. So, that wasted power is known as reactive power. So, while understanding this power factor, so this power triangle is the same power triangle as I have given you along the river side. It is real power Vi cos phi. So, hypotenuse, it is the apparent power which we say Vi, and perpendicular power is known as reactive power, which is known as kilovolt ampere reactive. So, this is the same, again we have the power factor is equal to cosine of an angle. So, it is power triangle. So, it is real power which is represented by P. There is a reactive power which is represented by kVAR, and there is a apparent power kVA. So, while changing the angle theta, so the power factor can be varied from 1 to 0. So, ideal power factor is 1, which is very good power factor, but when theta is equal to 90 degree, so the power factor is 0, which is impossible, and the total power is wasted in the electrical circuit. No real power is consumed in the electric circuit. So, again we can see, so this is pure real power, again apparent power and reactive power. So, cos phi, so we can have different values of cos phi. So, by changing the angle we can find the different values of cos phi. Now, over here you see, if the angle theta is equal to 0, power factor is 1, and which is the most desirable power factor in any industry, in any installation. So, this we want in any industry. So, when the angle theta is 45, the power factor is 0.707, so which is less required, and when angle theta is equal to 90 degree, power factor is equal to 0, that is totally wrong. So, this totally the total power applied to the machine is wasted by the machine, and no real work is done by the machine in this case. So, up till now we have studied that the horse which is pulling the load along the river, when it is pulling the load along the river, it consumes the real power. So, when the horse pulls the load at an angle theta, it consumes more power, which is the combination of real power and the power wasted by the horse doing extra work. So, the load is same, the load pulled by the horse is same, but the horse is doing an extra power, applying extra power to pull the load for this purpose. Now, this is how I want to explain and want to try myself, so that you can understand what the power factor is. So, what is the inside story of the power factor? This is my small collection of slides, so that you can understand power factor. So, after that we will study the disadvantages of power factor. So, as you know, in single phase the power is equal to VI cos phi, in 3 phase power is equal to 3 under root 3 VL IL cos phi, line current and line voltage. So, in both the cases you see load current is inversely proportional to power factor. So, if the load current is inversely proportional to power factor, it means lesser is the power factor, more is the current. Greater is the power factor, lesser is the current. So, in this case, from above equation, load current is inversely proportional to the power factor for constant power and voltage, and for low power factor load current increases, higher current results in following disadvantage. So, I have already told you lower is the power factor, higher is the current, more is the current. If the current is more, then there are some disadvantages which creates in our power system. First of all, if we have more current, we require greater conductor size. So, we have greater conductor size, in which we have to spend more money to buy the conductor for the same load. Next, we have larger copper losses. Definitely, if we have a conductor then the resistance of that conductor is fixed. If more current is flowing through that line, the copper losses are going to be, if the current is double, the copper losses are to be 4 times. So that is the reason. So this is one of the biggest disadvantage if we have lower power factor. Then we have poor voltage regulation. So for the lower power factor or lagging power factor, current magnitude increases, hence voltage drop in all the equipments connected in the lines such as alternators, transformers and transmission lines increases. At the receiving end, the voltage which we receive the voltage, the difference between the sending end voltage and receiving end voltage becomes more and more, and we have poor voltage regulations. And the last is while you see from here kVA rating of the equipment, or it is known as larger kVA rating of the equipment for the same load. So let us I will give you the example. Suppose I have a 50 kilowatt motor which is run at 0.5 power factor. So when a 50 kilowatt motor which is run at 0.5 power factor, so this 50 kilowatt motor is loading 100 kVA transformer fully. But if you improve your factor to 1, so we can run 2 similar 50 kilowatt motor each at the same transformer. So we cannot remove the load, we cannot decrease the load, but the rating of the equipment has to be increased. So this is one of the most bad disadvantage of our power factor. So we have to increase the ratings of our equipment, which is again huge loss of money in the process. So now we have to study about the causes of low power factor. So students, ਜਿੰਨਾ ਚਿਰ ਸਾਨੂੰ ਇਹ ਨਾ ਪਤਾ ਲੱਗੇਗਾ ਕਿ ਪਾਵਰ ਫੈਕਟਰ ਕਿਹੜੀਆਂ ਗੱਲਾਂ ਤੇ ਘਟਦਾ ਹੈ, so this is one of the most important thing to be remembered, that which things are causes to have lower power factor. So first of all AC motors except overexcited synchronous motor, ਅੱਗੇ ਜਾ ਕੇ ਅਸੀਂ ਪੜਾਂਗੇ ਇਹ, and a transformer operated at lagging power factor, the power factor falls with decrease in load. For example, an induction motor has reasonable higher as follow as electric discharge lamp operates at lower lagging power factor. So I want to explain you in your language. ਕੋਸ਼ਿਸ਼ ਕਰੋ ਇੰਡਕਸ਼ਨ ਮੋਟਰਾਂ ਨੂੰ ਫੁੱਲੀ ਲੋਡ ਤੇ ਚਲਾਉਣ ਦੀ. ਸੋ ਐਜ਼ ਯੂ ਗੋ ਔਨ ਤੁਸੀਂ ਇੰਡਕਸ਼ਨ ਮੋਟਰ ਤੇ ਲੋਡ ਘਟਾਈ ਜਾਓਗੇ ਤਾਂ ਜਿਹੜਾ ਪਾਵਰ ਫੈਕਟਰ ਹੈ ਉਹ ਘਟਦਾ ਜਾਏਗਾ, ਲੈਗਿੰਗ ਹੁੰਦਾ ਜਾਏਗਾ. ਸੋ at no load in the induction motor draws more magnetizing current but less real power. So at full load motor draws more real power but less magnetizing current. Magnetizing current does not change from no load to full load, but the real power changes from no load to full load. So the power factor go on improving from no load to full load. So always try to run your machinery at higher loads, at fully loaded machines. So the power factor, so causes, we are studying about the causes of low power factor. The next cause of lower power factor is due to increase in supply main voltage. So ਕਈ ਵਾਰੀ ਅਸੀਂ ਸਾਡੇ peak hours ਹੁੰਦੇ ਜਦੋਂ they are lunch hours ਜਾਂ night hours, ਜਿਹੜੇ ਸਾਡੇ peak hours ਹੁੰਦੇ ਆ, we have to increase the magnetizing current of our alternators. So by increasing the magnetizing current of the alternators, so with that you see when the magnetizing current will increase, you can study in case of a transformer the magnetizing current always lags the voltage by 90 degree, exactly lags the voltage. So magnetizing current is purely inductive current. So as we go on increasing the magnetizing current, the power factor go on decreasing. So next cause is the power factor at which motors operate falls due to improper maintenance. ਸੋ ਇਹ ਬਹੁਤ ਜ਼ਰੂਰੀ ਗੱਲ ਹੈ ਕਿ ਅਸੀਂ ਇਲੈਕਟ੍ਰੀਕਲ ਮੋਟਰ ਸਪੈਸ਼ਲੀ ਜੋ ਜਿਨ੍ਹਾਂ ਦੇ ਘਰਾਂ 'ਚ ਜਾਂ ਇੰਡਸਟਰੀ 'ਚ ਮੋਟਰਾਂ ਲੱਗੀਆਂ ਹੋਈਆਂ ਉਸ ਦੇ ਪਾਵਰ ਫੈਕਟਰ ਨੂੰ ਇੰਪਰੂਵ ਕਰਨ ਲਈ ਉਹਨਾਂ ਦੀ ਪ੍ਰੋਪਰ ਮੇਨਟੇਨੈਂਸ ਕੀਤੀ ਜਾਵੇ, ਉਹਨਾਂ ਦੇ ਬੀਅਰਿੰਗਸ ਨੂੰ ਚੈੱਕ ਕੀਤਾ ਜਾਵੇ, ਵਾਰਨ ਆਊਟ ਬੀਅਰਿੰਗਸ ਨੂੰ ਚੇਂਜ ਕੀਤਾ ਜਾਵੇ, ਸੋ ਤਾਂ ਕਿ ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਫ੍ਰਿਕਸ਼ਨ ਜਿਹੜੀ ਘਟਾਈ ਜਾਵੇ ਔਰ ਪਾਵਰ ਫੈਕਟਰ ਨੂੰ ਇੰਪਰੂਵ ਕੀਤਾ ਜਾਵੇ. ਸੋ ਵਾਰਨ ਆਊਟ ਬੀਅਰਿੰਗ ਜਿਹੜੇ ਹੈਗੇ they have to be replaced by new one after some time, so to improve the power factor. So sometimes some metal is removed. ਤੁਸੀਂ ਦੇਖਿਆ ਹੋਏਗਾ ਕਿ ਅਸੀਂ ਕਈ ਵਾਰੀ ਆਪਣੀਆਂ ਮੋਟਰਾਂ ਨੂੰ ਸਾਡੀ ਮੋਟਰ ਸੜ ਜਾਂਦੀ ਹੈ ਤੇ ਅਸੀਂ ਆਮ ਇੱਕ ਮਕੈਨਿਕ ਮੋਟਰ ਮਕੈਨਿਕ ਕੋਲ ਚਲੇ ਜਾਂਦੇ ਹਾਂ. ਉਹ ਮੋਟਰ ਮਕੈਨਿਕ ਮੈਂ ਇਹ ਨਹੀਂ ਕਹਿੰਦਾ ਕਿ ਉਹ ਅਨਪੜ੍ਹ ਹੁੰਦੇ ਆ, ਸੋ ਉਹ ਇੰਨਾ ਇਲੈਕਟ੍ਰੀਕਲੀ ਉਹ ਮੋਟਰਾਂ ਨੂੰ ਨਹੀਂ ਜਾਣਦੇ. ਜਦੋਂ ਉਹ ਰੀਵਾਈਂਡ ਕਰਦੇ ਆ ਤਾਂ ਉਸ ਤਾਰ ਦੀ ਜਿਹੜੀ ਉਹ ਡਾਇਆਮੀਟਰ ਉਹਨੂੰ ਚੇਂਜ ਕਰ ਦਿੰਦੇ ਆ, ਟਰਨਾਂ ਨੂੰ ਘਟਾ ਦਿੰਦੇ ਆ, ਜਿਹਦੇ ਕਰਕੇ ਸਾਡਾ ਮੈਗਨੇਟਾਈਜ਼ਿੰਗ ਕਰੰਟ ਜਿਹੜਾ ਵੱਧ ਜਾਂਦਾ. ਐਂਡ ਵੈਨ ਵੀ ਰੀਇੰਸਟਾਲ ਦਾ ਮੋਟਰ ਜਿਹੜੀ ਸਾਡੀ ਲੋ ਐਂਡ ਲੈਗਿੰਗ ਪਾਵਰ ਫੈਕਟਰ 'ਤੇ ਕੰਮ ਕਰਨ ਲੱਗ ਪੈਂਦੀ ਹੈ. ਸੋ ਦਿਸ ਇਜ਼ ਵਨ ਆਫ ਦਾ ਮੇਨ ਕਾਜ਼. So try to replace if your motor is has demanding some repair or the motor is worn out, then it should be repaired by a proper factory mechanic. So try to see the air gap between the rotor and stator. If the air gap is more, then the power factor is low and lagging. So these are the factors. So next is industrial heating furnaces such as arc and induction furnaces operate on very lagging power factor. So arc furnaces they also one of the reasons of making power factor low and lagging. So next is, so we have studies up till now the causes of power factor. Power factor low ਹੋਣ ਦੇ causes ਅਸੀਂ ਪੜ੍ਹੇ ਆ. Now we will study next power factor improvement equipment. So how to improve the power factor? So what are the various methods to improve the power factor? So we have seen the horse when pulled a load by an angle theta to the river side. So he is using extra energy to pull the same load, and that extra energy is wastage of energy. So we don't want similarly in electric system we don't want to waste energy. So in this world or in India, which is our developing country, we required more and more power, and if we are going to waste this power like this, so we cannot develop. So we have to improve our power factor. So by providing some system, so we can improve the power factor by connecting a suitable system in parallel with our load to improve it. So I have already told you we have a capacitor which draws a leading current with the voltage. So capacitor is one of the best method to improve the power factor. So first is static capacitor. So static capacitor, as you have seen in case of a ceiling fan, there is a capacitor which is valued in microfarads, so which is connected in the circuit of a ceiling fan. So that capacitor also improves the power factor of the ceiling fan. Then we have synchronous condensers, and then we have phase advancers. So we will study all these three systems one by one. The first is static capacitors. So stator capacitor is capacitors of many kinds. So power factor can be improved by connecting the stator capacitor in parallel with the equipment which draws leading current. So this is one of the correction in my slide. So it's not lagging, it's a leading current. So capacitor bank is connected in star or delta. So, you can see in your powerhouses, in substations, there is a capacitor bank are installed over there. These capacitors are connected in star or delta. For very poor power factor load, capacitors are connected in delta, as power drawn by the delta is 3 times that of the star connection. So, this is the connections. So, these are, you see we have a 3 phase load, red, yellow, blue. So, this